The National Electrical Code, or NEC, mandates that all metallic piping systems and equipment containing gas must maintain electrical continuity and be bonded to the grounding electrode system. This requirement ensures that any stray electrical current is safely conducted back to the source, preventing potential hazards such as electrical shock or fire. However, a distinction is made when flexible gas piping systems are constructed using non-metallic materials. Specifically, if the flexible gas piping system is made entirely of non-metallic materials, such as certain types of plastic, bonding is not required by the NEC. The presence of a UV-resistant polyethylene jacket on a flexible gas piping system does not automatically necessitate bonding. The critical factor is whether the piping itself is metallic or non-metallic. If the piping beneath the polyethylene jacket is metallic, then the bonding requirements of the NEC apply. If the piping is non-metallic, bonding is not required. To determine whether a flexible gas piping system requires bonding, firstly, identify the material composition of the piping itself. If the piping is metallic, ensure that it is electrically continuous. This means that all sections of the piping are securely connected to each other to form a continuous electrical path. Secondly, bond the metallic gas piping system to the grounding electrode system. This is typically achieved by connecting a bonding conductor from the gas piping to a grounding electrode, such as a ground rod, metal water pipe, or building steel. The size of the bonding conductor must be determined based on the size of the service entrance conductors according to NEC Table 250.66. Thirdly, inspect the connections to ensure they're tight and secure. Loose connections can compromise the electrical continuity of the system and reduce the effectiveness of the bonding. If the piping is non-metallic, no bonding is required. However, it is still important to ensure that the piping is properly installed and supported, in accordance with the manufacturer's instructions and other applicable codes. The grounding electrode system is a network of interconnected grounding electrodes that provide a low impedance path for fault current to return to the source. Common grounding electrodes include ground rods, metal water pipes, and building steel. The grounding electrode system must be properly installed and maintained to ensure its effectiveness. The bonding conductor is a conductor that connects metallic parts of the electrical system to the grounding electrode system. The bonding conductor must be sized appropriately for the size of the service entrance conductors, as specified in NEC Table 250.66. The purpose of bonding is to create a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. This helps to prevent electrical shock and fire hazards. Electrical continuity refers to the ability of a metallic piping system to conduct electrical current. Electrical continuity is essential for effective bonding. If the piping system is not electrically continuous, fault current may not be able to flow back to the source, and the bonding system will be ineffective. The NEC specifies requirements for maintaining electrical continuity in metallic piping systems. These requirements include using the appropriate fittings and connectors, and ensuring that all connections are tight and secure. Polyethylene is a type of plastic that is commonly used as a jacket for flexible gas piping. Polyethylene is resistant to ultraviolet radiation, which can degrade other types of plastic. The polyethylene jacket helps to protect the gas piping from the elements and extend its lifespan. However, the presence of a polyethylene jacket does not change the bonding requirements for the gas piping system. The bonding requirements are determined by the material composition of the piping itself, not the jacket. In summary, the NEC requires bonding of metallic gas piping systems to ensure electrical safety. Flexible gas piping systems made of non-metallic materials do not require bonding. The presence of a polyethylene jacket does not affect the bonding requirements. Always consult the NEC and local codes for specific requirements and guidance. It is always advised to seek a licensed and qualified electrician for gas piping system installation. The size of the grounding electrode conductor is determined by NEC Table 250.66. This table specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. For example, if the service entrance conductors are 4/0 American wire gauge copper, The minimum size of the grounding electrode conductor is 2 American wire gauge copper. The bonding jumper is a conductor that connects metallic parts of the electrical system together. The bonding jumper must be sized appropriately for the size of the circuit conductors, as specified in NEC Table 250.102. The purpose of the bonding jumper is to create a low impedance path for fault current to flow between metallic parts of the electrical system. This helps to prevent voltage differences between metallic parts, which can cause electrical shock. The equipment grounding conductor is a conductor that connects the non-current carrying metallic parts of electrical equipment to the grounding electrode system. The equipment grounding conductor must be sized appropriately for the size of the circuit conductors, as specified in NEC Table 250.122. The purpose of the equipment grounding conductor is to provide a low impedance path for fault current to flow back to the source. This helps to trip the circuit breaker or fuse and de-energize the circuit, preventing electrical shock and fire hazards. Ground fault circuit interrupters, or GFCIs, are devices that protect against electrical shock by detecting ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. GFCIs are designed to trip quickly when a ground fault is detected, interrupting the flow of current and preventing electrical shock. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or SIs, are devices that protect against electrical fires by detecting arc faults. An arc fault is an unintentional electrical discharge that can occur when wires are damaged or connections are loose. SIs are designed to trip quickly when an arc fault is detected, interrupting the flow of current and preventing electrical fires. SIs are required in certain locations, such as bedrooms and living rooms. Surge protective devices, or SPDs, are devices that protect against voltage surges. Voltage surges are brief spikes in voltage that can damage or destroy electronic equipment. SPD are designed to divert voltage surges away from sensitive equipment, protecting them from damage. SPD are often installed at the service entrance to protect the entire electrical system. The National Fire Protection Association, or NFPA, is an organization that develops and publishes codes and standards related to fire safety. The NEC is one of the codes developed by the NFPA. The NEC is updated every 3 years, and it is widely adopted by jurisdictions throughout the United States. The Underwriters Laboratories, or UL, is an organization that tests and certifies products for safety. UL-listed products have been tested and found to meet UL safety standards. Many electrical products are required to be UL-listed. The International Association of Electrical Inspectors, or IE, is an organization that provides education and training to electrical inspectors. The IE also publishes guidelines and interpretations of the NEC. A qualified electrical inspector can provide guidance on the proper installation and maintenance of electrical systems. Understanding the specific requirements for bonding and grounding gas piping systems is crucial for ensuring safety and compliance with electrical codes. Always refer to the latest edition of the NEC and consult with a qualified electrician for specific applications. Proper installation and maintenance of grounding and bonding systems are essential for preventing electrical hazards and protecting people and property. Remember to always prioritize safety when working with electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician.